Summary of Tableau 5. Towards an axiomatic theory of probability, the abstract probability space. In moving to an axiomatic framework, we identify three fundamental elements which underlie games of chance. The first, the identification of the sample space omega, which is the conceptual space of all possible conceivable outcomes of a thought experiment, a Gedanken experiment. This was the object identified by von Mises, and it's a starting point in a probabilistic endeavor, identifying what the space of possibilities is. The second element, the idea of an event as a subset of idealized outcomes, a subset of the sample space. The collection of events forms an algebra of events where, as with an ordinary algebra, we can massage objects using unions, intersections, set differences, and complements. And the third and final element, the assignment of a probability measure, a set function to events. Now, the idea of a probability measure is complicated on the surface. If it is to fit in with our understanding of probability intuitively, it must satisfy, we must ascribe to it three axioms: the axiom of positivity, the axiom of normalization, and the axiom of additivity. But this is a very complicated object. This is not our grandfather's function. It's a set function. It's complex. Its arguments are sets. And all these interrelationships between events are difficult to keep track of, especially in large spaces. So a natural question then is, how does one construct a probability measure? We shall come to this. Okay? Ideally, of course, our constructions will reflect an intuitive reality, the feeling we have that if we perform a chance experiment independently, repeatedly, then the frequency of occurrence of an event should be reflected in this probability. And indeed, we'll find in our culminating lectures that this, in fact, is the case, and this establishes the framework for why we believe in such a theory of chance. Now, from an abstract point of view, this axiomatic structure immediately gives us certain low-hanging fruit, simple consequences, and these we should have under our belts. First, the empty set has got zero probability. An immediate consequence of this is that probabilities are bounded between 0 and 1. The bookend 0 for the empty set and 1 for the sample space. Monotonicity, the key and important property, is also an immediate consequence. If two sets of events satisfy inclusion relationships, then the probability will follow in the natural direction. A consequence of this is the subtle inequality of Boole. The probability of a union of events is no larger than the sum of the individual probabilities. Additivity comes to the fore again when you talk about partitions. If you partition the sample space into disjoint elements, then the sum of the probabilities of those elements must be 1. And a consequence of this is this identity of inclusion and exclusion, which connects the probabilities of disjunctions or unions on one hand to the probabilities of intersections on the other. Now, before we move on, these basic ideas are so important that we should really take stock. Right? Bear in mind that the key elements here are three in number: the sample space, the algebra of events, and the probability measure. Long experience has taught me that when a student who is new to the subject is confronted with a problem, her first reaction is to scrub around, look for a formula, something you can plug in, something and get an answer quickly. This is usually ill-advised. The first step in a problem in chance always involves the following idea. Can you identify the chance elements of the problem at hand? here is the acid test for whether you can identify these. If you tell me here is a putative sample point or idealized outcome of the experiment, then the moment that sample point is identified, there can be no residual uncertainty as to what happened in the experiment. To make this concrete, imagine an experiment where one throws 2 dice. Well, what are the outcomes? If one were to say incautiously that the outcome is a number from 1 through 6, well, that leaves a lot of things uncertain. Which die are we talking about? And pray, what happened to the other die? To come to a right understanding of what really happened, one will have to specify what happened to each of the 2 dice. One has to have then a convention for describing what we mean. So, for example, we could say a pair of numbers, 3 and 6, meaning that the die which is color red showed 3, and the die which is color white showed 6. There's a convention here, a dictionary of translation, which is established ahead of time, which explains what the conventions are. And at the end of the day, a pair like 3, 6 tells us exactly what happened when one threw those 2 dice. This is our acid test. When you specify sample points, when you specify the sample space, the moment one specifies a sample point, there can be no residual uncertainty in what happened in the experiment. Of course, there are many different ways then of specifying in notation complex experiments. Pick one. Once you have this under your belt, now we have a representation for these idealized outcomes, for these sample points. Identify the key events of interest. And bear in mind that an event must perforce be a sub-collection, a subset of the sample points you've identified. If one cannot identify exactly the subset under discussion, then one is already in deep, hot water. One doesn't know what the object is for which we're going to try to ascribe a probability. And of course, we can only expect that bad things will come out of such a lack of coherence. So, the second step has to be, once you identify the sample space as a set, which subsets of that space are interesting for our problem? These are the events at hand. And the third and final step, of course, is to ascribe to the events of interest a probability, which satisfies the basic axioms of probability. So our next step would be to say, well, how does one construct probability measure? This looks like a very complex and complicated object. It is a set function for crying out loud. And of course, we turn to elementary examples for which we have a lot of intuition to see how we might proceed. This is the subject of our next tableau.